Good morning everyone. So today we will study the derivation of the broglie wavelength. So now we know that the energy of a photon is given by E equal to h mu. No? So where mu is frequency, h is Planck constant. Now if m is the mass of the photon, then as per mass energy equivalency, E equal to mc square. So this is the, I hope you know this equation. This is the famous Einstein relativistic equation, E equal to mc square. This equation means we can convert mass into energy and energy into mass. So we have two formula for energy. One is this one, E equal to mc or E equal to h mu, and the second one is E equal to mc square. So now from equation 1 and 2, okay, here we have to find what? Wavelength. Wavelength is lambda. So from 1 and 2 we can equate this equation because both of them are energy only. So h mu will be equal to mc square. From equation 1 and 2, h mu equal to mc square. Now keep m in one side, so take c square in the other side of the equation. So that means it will go downside, c square. That means m equal to h mu by c square. So m equal to h mu by c square. Right. So make this equation 3. Now photon. Now photon move with a constant speed. Okay, what is photon? Photon is light, right? But it the speed of light is constant, and it is given by, represented by c. So momentum of a photon will be, so momentum formula is what? Momentum equal to mass into velocity. So momentum of photon equal to mass of photon. Mass of photon is given. This is if m is taking as dynamic mass of a photon. So mass of photon is m into velocity. Velocity of photon means velocity of light. So it is c. So mc. So this is the momentum of photon. Now what is m? M is this one. M equal to h mu by c square. So h mu by c square. H mu by c square into this c. So one c and one c will cancel. Now we will have h mu by c, right? Now next step is bring this. Okay, we know that this lambda equal to c by mu. Class 11 wave chapter, last chapter, we have studied this one. So using this mu I can take downside here, right? So it will go up, right? So just keep it downside here. So now what is c by mu? C by mu. So this is c by mu. So in place of c by mu we keep lambda. So what we have to find? We have to find lambda. So bring lambda in one side and bring this mu or this momentum in this side. So P equal to h by lambda. So this is the equation. This is the equation, this one. Okay. Now bring this lambda in, keep in one side. Okay, now so if we change this p to other side, so it will go downside, nah? So this is the uh de Broglie wavelength. Okay, lambda equal to h by p, but we have to find de Broglie wavelength for matter. Okay, matter wave. So matter means it will have some velocity v. Okay, so this equation is applicable for matter wave too. Okay, this equation is for photon, na? Photon is radiation, right? So how to convert this into matter one? So this equation is applicable for matter wave too. So if a material particles of mass m, no, mass m moving with a speed v has a momentum. So now momentum, this is momentum, nah? Momentum for matter is how much? Momentum will have some velocity, nah? For matter we will not use c. Okay, c is for photon only, nah? So now instead of c you will write velocity v. Okay, so h by p will be equal to h by mv, nah? For photon don't use this mv. For photons it will be mc. Okay, this p is not photon. Okay, this p is momentum. Momentum is denoted by p. Okay, so this equation is de Broglie wavelength. So de Broglie wavelength for matter wave, for matter.